Hello, welcome everybody to channel Sube. Today I am going to discuss question number 27 of 2019 Physics New Syllabus paper, the MCQ part. A large number of point charges are uniformly spread out over a non-conducting ring of radius r. If the total charge on the ring is capital Q, what is the electrostatic potential at point P on the axis of the ring as shown in the figure? So there are 5 answers. So let's add some parts to the diagram they have given. So they say there is a charge whose amount is Q. So like this, the charges are on the ring like this, spread out. The total charge is given as capital Q. So first of all, you have to visualize the question properly in your mind. Then the total amount of charge is given as Q. So what they ask is, what is the electrostatic potential at point P? So point P is this one. So the potential, what is the symbol for potential? V. They ask the value for V. So children, what is the equation for V? If we revise the lesson, first of all, what is the first equation we learn in this electrostatic lesson, the lesson electrostatic? F equals 1 over 4 pi epsilon naught Q1 Q2 by d squared. That is the first equation we learn. Then what is the second equation? All these are vectors. E equals 4 pi epsilon naught Q divided by d squared. So this first equation we apply to point charges like this for 2 point charges, and what we get as F, the force between those 2 point charges. So that is the equation for such a system. So what is this E? That is the field strength. Sometimes we call field intensity. So that is for one charge. There is a charge, the amount, the quantity is Q, and there are Q charges. So like this. So from this charge, so in the first equation the D is this one, the distance between both charges Q1 and Q2. So here when we measure the field intensity, we consider only one charge, that is this Q. Then what is this E? Around this charge there is a field. Around this charge there is a field like this. We draw it like this using arrows. There is a field. Field means there is an influence, attraction or repulsion. So that influence is spread around this charge. Influence. So if we place the charge, another charge here, either it is repelled, or if it is a negative, since the main charge is positive, it attracts. So attraction or repulsion. there is an influence like that. So the strength of that influence is called E, but the definition is, what is the definition? The idea is that the definition is, if we place the 1 coulomb, positive 1 coulomb, a charge here, a small object having a charge of positive 1 coulomb, positive, since it is positive, what happens? By this capital Q, this unit charge is repelled like this away from this charge, away from capital Q charge. So the force acting on that unit charge is defined as E. So the value E is, if the Q equals 1 coulomb, the force is known as E. If this Q, not this Q, the Q2, if this Q2 is equal, so this one is Q2, if this Q2 is equal to 1 coulomb, positive, it must be positive, then there is a force, isn't it? So that force is called capital E, field strength, that is called field strength. So that is the second equation. So all these two are vectors. Why we say so? We have to consider the direction, either this way or this way or this way or like that, the direction. So if we consider the direction, that is, that quantity is called a vector. So if we are asked to find the field intensity, this E at this point P, we have to consider the direction like this. So we have to draw arrows like this, and we have to get finally the resultant. We have to take cos theta sin theta if they asked E, or if they asked F, because they are vectors. But what they ask is potential V. So what is the equation for potential? V equals 1 over 4 pi epsilon naught Q divided by D, not T squared. There is no power 2 here. So you have to say it again and again when you write this equation, otherwise you will forget it. To penetrate into your mind, you must repeat it all the times you write this equation. V equals 1 over 4 pi epsilon naught Q divided by D no squared, like that. Then this is the equation now we have to use. So what is this V? Is it a vector? No. Is it a vector or a scalar? It is a scalar. Why do we say so? What is the definition for V? Potential. What is the definition for potential at a point? So imagine the Q, the charge is here, this Q. Now we are now referring to this equation. This Q is here like this. So away from that charge, the distance D, there is a point. So at that point they ask, what is the potential V? What is the meaning of that V? What is the definition? You must know the definition, otherwise you have no idea. You might find what is V. V equals such and such values and such and such units, but you have no idea what is it if you don't know the definition. The definition for potential is the energy, the work done to bring a unit positive charge from infinity to that point without acceleration. We have to spend energy. Why? If we bring 1 coulomb from infinity to this point where they point out, because this one is positive, this one also positive, what happens? By this one, this second charge, the unit charge, is repelled like this. So it is very difficult to bring here. Overcoming this force, opposite force, we have to push it with a big force, then the force repelling bigger force, greater force than this one. So we have to spend energy, some amount of energy, because it is difficult under repelling condition. We have to bring it to here, so we have to spend some energy. So that energy is called potential. For 1 coulomb, that is also positive, it must be positive. For positive unit charge, the energy we have to spend is called potential at a point. So this second charge, this second charge is the Q2. So this Q2 is equal to 1 coulomb. Therefore it is not included in the equation, because multiplied by 1 is we don't have to write, meaningless if we write like this. Therefore that Q2 is 1, so it is not appeared in this equation. So energy, it is an energy. This one is an energy. So the next question is it a vector or a scalar? Energy. Is energy a vector or a scalar? So I say energy is a scalar, not a vector. Why? Imagine you focus your mind to energies we use in day-to-day life. Think about a battery. If the battery is dead, we know. If the battery is fully charged, we know. If the voltage of the battery is decreased, we can identify it. If the battery is fully charged, we can identify it. Imagine this one is a battery of a phone, battery of a cell phone. So I like it. So I draw it like the same way. So this one is the battery of your cell phone. So if it is discharged, you can identify it because the phone indicates it. If it is fully charged, you can identify it. But do you consider a direction? Is there an indicator saying in the phone that this direction is to north, the battery of the charge of the battery is to north, or the charge of the battery is to south, or horizontally upwards, or vertically upwards, or vertically downwards? Is there an indicator? No. That means we don't care, we don't consider the direction. There is no direction. Just a value. It has only a value. The energy has only a value. We don't have to consider any direction because energy has no any direction, only it has a value. So therefore energy is not a vector. Therefore we don't have to, as I said earlier, we don't have to find directions like this when we try to solve this question. Just we have to find out the value. Therefore we have to substitute to the equation and just find the value. So we write the equation like this. Now the problem is, we know Q, we know this Q that is given here, this Q, but the problem is how to find out D. You know this, what you learn in the classroom in your lesson is this one. You don't learn something like this. You might learn, but normally you learn this thing. So we have to simplify this diagram to what you learn. So I copied it. So imagine these charges. So what is the direction? What is the D? What is the distance to this point charge? So we know we need the distance from this Q to this point. what we learn in the classroom is this one. So we need this d. So these small charges are spread out like this. So the distance is for this small charge, the distance is this one. For this small charge, the distance is this one. So this is small charge, the distance is this one. So what do you think, the distance? Does it change from charge to charge or no? Is it same or change? Say this one is d, then this distance, what do you think? d1 or d2 or something like that? No, it is the same, because this ring is horizontally placed, this axis is vertically placed, so they are perpendicular to each other. So therefore all the distances from each small charge is same. Therefore we can accumulate, we can get all these things, we can collect all these charges into one place like this. Into one place like this we can collect them, we can gather all these charges to one place and mark the distance, this distance, as this distance like this. So this is the distance. Since we don't have to care the direction, directions are different, but we don't have to care the direction because this potential is a scalar, it is not a vector. Therefore only the direction, only the value, only the magnitude is what we need. So say that distance is d. So from each other charges also the distance is the same, d. Therefore we can collect all these charges to one point like this and get the distance d, a single one, a single d, because all these are equal. So charge is q. So now the question is how to find out this d. This d, it is very simple, because we know Pythagoras theorem. So there is an orthogonal triangle or there is an right angled triangle. This one is 90 degrees. So can't we find this d? We can. So what is the equation? D equals, this one is called r, this one is called d. So d squared plus r squared, the root of whole thing. So that is equal to this d. So only that thing we have to do. Now we almost solved. V equals 4 pi epsilon naught, q they have given as q. So what is d? Root that d, what they have given d, this vertical d. So that d squared minus r squared. So that is the answer, children. This one, no, the fourth one, this one is the answer. So children, I think you can understand it. So I started from the beginning itself. So if you are happy, please subscribe my channel. Thank you very much for watching my videos. Do it again and again. See you tomorrow. Goodbye.